Okay. Screen's very big today. Maybe, Sophie, can you move it left? Yeah, a bit more. More. Yeah, that's better. Okay. Oh, come on. Well, I'll draw with my mouse first. You remember the alternating current? It goes up, down, up, down, up, down, back, forward, back, forward. So let's just imagine that the top here was, I don't know, 200, and the bottom here was minus 200. What? How do you think we could measure the average voltage? Maybe if I graph it for you. There we go. For example, in the first question, what was the maximum voltage? Have you got it there? Do you have the question?
I didn't write down.
One, two, one.
Very first question, what was the maximum voltage?
110.
110, was it? Okay. Is that what I said the maximum was, or the average? It must be maximum. So,
You asked what is the maximum.
oh, I asked what's the maximum. Okay. So let me give you the idea for this. When we look at the voltage, we don't care if it's positive or negative for these problems. So if we look at the positive only, the graph instead looks like this. So the voltage goes up and down and up and down and up and down. And we want to know what the average is. So let's call the maximum up here something like V max. Yeah? What do you think would be a good measure for what the average voltage is? Sometimes it's small, sometimes it's big. What do you think? Yeah, this is a good guess. So you're thinking the average is somewhere in the middle. In fact, there's a formula here for the average. The average voltage is equal to the maximum voltage divided by, and it's actually not 2, it's root 2. Now the reason for that, I can't tell you. Because, well, I could tell you, but it's not something you do with Joan in maths class. But it's to do with the fact that this is a sine curve. So Hareen, you said maybe it could be the maximum minus the minimum divided by 2. And that would be true if the graph was like this. If it was a linear graph. In fact, because it's a sine curve, we have to put in root 2. This is something, I can't tell you why. I'm sorry.
What is average?
Average, yeah.
We skip the V because it's
We skip which?
V max, V minimum because it's
Yeah, I suppose it's like V max minus V min, it's 0. But it's the minimum's always 0 for the AC current. This is the formula here. Not V average equals V max divided by 2. So in the question, I tell you that the average is 110. So that means the maximum will be 100. What would it be? What is this? 110 root 2. 152, is it?
One hundred
156 then. That's the maximum voltage. Let's have a look at the next question. Do you have the next question written down?
Yes.
Oh, okay. Well, then you can read it to me.
Okay, 156.
Yeah, 156. Sorry, it was ugly.
2 Vmax.
Huh?
Vmax.
Vmax, yeah.
With
110 root 2. I use this formula because I give you this in the question, and I want this one. Okay. Great. What's the second question?
1 meter up per pipe lines on the ground going east to west,
East to west, 1 meter. Okay.
and a person picks up the pipe and rotates it from 180 degrees, so it's still like this way. If it takes 2 seconds to rotate the pipe, then what is the
Induced.
EMF
Great.
in the pipe due to the Earth's magnetic field density of 0.07
Millitesla. So what happens here is you have the copper pipe on the ground, and as you turn the copper pipe, you get a current, because it's like you're turning the magnet. Do you get what I'm saying? Yeah. You're moving the field. Yeah?
Turning it gets current.
Huh?
Turning it gets current.
Yeah, when it's turning. Yeah. Yeah. Okay, so how long is this? You lift the pipe up, or you turn the, hang on. What did I say? You turn the pipe for 2 seconds, isn't it? Yeah. Now I think I'll have to change this question a little bit because I don't have pipe in the right position. I said it's on the ground, but yeah, I think I should have said the pipe is standing up on the ground and you turn it. Is that what I meant? Hang on. Which rule do I need? Left or right hand? Right hand rule. So the motion would be upwards. F, B, I, F, up, B, up, current, to the left. Yeah, okay, so I think I have this right. If I were to turn this, F is up this way, that's the F. The magnet is going up, so it's like this. Yeah, I don't have it the right way. I'll have to redraw it. Let's try this again. So this is the B. Yeah, sorry, I said the pipe was lying east-west and then you turn it. I meant to say that the pipe was lying north-south and then you turn it like this if you're looking. Imagine this is north and this is the pipe here. In the question I said it was lying this way. I should have said it was lying this way. So I turn it this way around. In my question I said I turned it this way around. No, the numbers are all the same, it's just my picture is wrong, but I still do the question the same way. I should have said the pipe was this way, and then you turn it like that. Instead I said it was like this, and you turn it like that. The difference is just with my right hand. So if you look, this one here is the F. So that's the F here, okay? And the magnet is going this way, yeah. So the current runs across the pipe like this. So the current goes from this side of the pipe to this side. It runs this way, not that way. Not that it's important. It doesn't change the number value. It just changes the direction. So when I flip it like this, let's see. Yeah, I'll get a current that runs to the left. But all the numbers are still the same. See, you missed this right-hand rule, didn't you? Did we do the right-hand rule this week, wasn't it?
Yes.
Yeah, you see, you missed all of this left-hand, right-hand stuff. Anyways, the formula, I won't worry about the minus.
Change the east to west to north to south.
That's it. Like Andy said, just change east to west to north to south. Okay, so what's changing here? The area or the magnet? The B, very good. Yeah, very good. How is the B changing though?
0 to 0, 0.07 units.
Yeah, if you look here, this is where you really have to use your imagination, okay? If I have the pipeline like this, and I turn it around, like that, that's the same as if I didn't move the pipe, and what? What way do I change the magnetic field? So, here, I turn it around this way. If I didn't turn it, that's the same as doing what to the magnetic field? In other words, if you're the pipe, yeah, what do you see the magnetic field doing?
Breaking, like moving around it.
Yeah, imagine you're the pipe, so the magnetic field is going north, this is your head, this is your feet, this is your head. So if I turn you around this way, for you it looks like the magnetic field gets moved around. So it's like you take the magnetic field and turn it around. You see, you missed all this. Now you'll have to watch the video when I upload it. Can you?
What's the name of the lecture?
It'll be uploaded today. Do you understand what I'm saying? Like if you were lying on the ground here and the magnetic field was going from your, like, no, look at me, please, look at me. Yeah. If you're lying on the ground, so here you are, this is your head, this is your feet, and if the magnetic field goes from your head to your feet, and then I turn you around, it looks like now it goes from your feet to your head. So it's like the magnetic field just gets flipped around. So at the beginning, it's 0.07 milli, but then afterwards it's minus 0.07 milli. Its direction changed.
Minus.
Yes, so the answer will be 0.07 millivolts.
The same as watching
Hmm? Head, look. Head, feet. If I flip you around, for you it looks like the magnetic field changed direction. First it was going to your head, now it's going to your feet. That's why the minus is here. No? No. Here. This is 0.07 millitesla, and this one here, minus 0.07 millitesla. Or if you want, you can call this one minus and this one plus. It doesn't matter. So the change would be this one minus this one. It's a bit like with the car, you know, if this was going 2 meters per second and then later it was going this way with 2 meters per second, the change is actually 4 meters per second because it's 2 minus 2. Or if you want, maybe I should really say minus 4. Minus 2 minus 2 minus 2. It's the same idea here. You're flipping the magnet around. So that's why the minus is there. Huh? No, in this one, yeah, this is minus 2, this is plus 2. So the change would be minus 2 minus plus 2. Oh, sorry. Bad handwriting. Okay now? Did anyone get this answer?
No, I get it.
But even further is minus.
I have I don't usually care about the signs. You're right, I have the sign wrong here, but I left the minus out here. There's actually a minus here. I don't really care about the sign because the sign is just for the direction. I only care about the voltage, how much. So if the question asks you the direction, you can use your right hand to get the direction anyways. Yeah, because it's just one pipe. It's not a wire. Can we do the next one? What's the next one, Andy?
A 2-meter horizontal copper pipe is brought from a cable 100 meters in Earth's magnetic field of density 0.07 millitesla.
Yeah.
The pipe lies east to west, so that the field is right angle. What is the induced EMF?
So in this picture here, north is into the page, okay? East is right, west is left, north is forwards. So let me see. Yeah. Before I started, I want everybody to tell me which way the current will move in the pipe using the right hand. Yeah? Which way is it? Which way is the current? To the north? No. No. To the east, I think. Look. Which way is the motion? Which way is the motion? Which way is the pipe moving? Which way is the motion? Down. And which way is the magnet? Into. To the north. To the North Pole, to Santa Claus.
North is not in here.
North is in three dimensions. North is forwards, yeah. The magnetic field. The pipe lies from east to west. So if I'm standing here and this is east and this is west, then north must be this way and south must be this way. Yeah?
So what does that have to do with the magnetic field?
You know the Earth has a magnetic field.
Yeah.
So this is the direction of the field. So this points to Santa Claus.
Oh. Okay.
Yeah. So anyway, which way is the current? From west to east.
Oh, but it could be that way as well, right?
What? Could be that way.
North could be in front, right? Could be behind.
Could it? Let's not worry about that. Confusing me. I don't think so.
Probably not.
Yeah. Anyways, you're happy that the current will go this way in the pipe as it falls? No. Great. You look so confused. You know what I'm doing here? The F is down. The B is this way. So the current is to the right. Current, yeah. What's changing here? The B or the A? The A is changing. You're getting more area as it falls. Triangle? No, it's UVATS.
I know it's UVATS.
Good. You do. U is 0, V we don't know, A is minus 9.81, T we don't know, and S is 100.
Is it minus 100?
Thank you. Minus 100. Thank you. This triangle. This one.
No. When that one falls down,
Yeah.
it's not like
Oh, no, it's straight down. As the pipe falls down like this.
what do you mean? Cut is a right angle.
My cut at right angle. Yeah, that means the pipe is this way and north-south is this way and it's 90 degrees. Hang on. If I look from the sky, okay, here's the going. Here's east, here's west, here's north, here's south. Here's my pipe, and here's my field. And I said cuts at right angles. I meant there's 90 degrees here. That's all I meant. Yeah? The area? It's getting bigger, yeah. As it falls. Yes?
I should remove all of my answers.
It's okay. Right, so I want you to get me, what do I need to know? I need to know where's my question going? I need to know the T. I don't care about the V. I need to know the t. Can you get me the t?
Yes.
Yeah, go on, give me the t. What formula do you need? I do. Don't give me that. S equals ut plus a half a t squared. That is right. So the t will be square root 100 over 4.905, which is, do the calculator. Four 4.52 seconds. Okay, so we'll use our formula now. The voltage will equal the change in that over the change in that. Oh rats! I just remembered I made a mistake here. What did I forget in my formula? BA. I forgot to multiply here by the A. Forget it. Do you know what? I don't like this question anymore, so you can delete it. Okay, so what's changing here, the B or the A? The A is changing, yeah, so it's the change in the A over the time. Okay, what's the area? What's the area at the end? 2 multiplied 100, yeah, so it's 200. No, it's still the same one, number 3. No, I cancel number 2. Yeah. And what's the area at the start? It's 0. Because it hasn't moved yet. And what's the B? It's 0.07 milli, isn't it?
Wait, which one did you cancel again?
Number 2, the second one I did, after the first, but before the third. Yes.
You're right all wrong.
Okay, on your calculator, can you calculate that, please? So here, I need 0.07 milli. It will show in a minute. Can you calculate it, please? Okay. There's a bit of a delay. You'll have to write down what Andy called out. What was the answer, Andy?
3.097.
Okay, so it'll just say 3.1 millivolts. And did you write the 0.07 in the front here? It didn't show up.
0.07.
Yeah, in the front. Because here, my pen's not writing. Decided to give up.
So then instead of 3, 0.0.
Here?
Yeah.
That's the 0.07 times the minus 3. Come on. Yes. Okay. Can we have a look at 4? Oh yeah, got it? Yeah.
What's the final
I'll try and fix my pen. The final answer is 3.1 millivolts. That's what you're doing. Okay. Okay, number 4. Oh, come on, pen.
All the time.
You should learn how to spell that word. It'll be useful for you. Okay, let's do number 4, but I need to close this because it's frozen. Okay, Grace, you have number 4?
What center of study?
Where are you studying now? Yeah. If you're sure your information is right.
No, yes. No.
Are you the principal? Are you? No.
Yes.
No. Are you the counsellor? No. Do not sign there, please. Porrick.
Oh.
Are you Porrick? No, you're not.
No. I
Yes, yes. Okay. Can you read number 4, please?
Copper wire is wrapped around in a circle loop 100 times of radius 5 cm around the magnet. The magnet of what density of...
No, you have to...
Read again.
Not my pen.
Should you open it?
I did open it. Oh!
I am right.
It's still alive.
1 centimeter.
Yes.
Old.
Well, what it is I need to put new ink in the top. Ink, so to speak. I think. But I need something to pull it out, but
Do you have nails?
no, I don't. Do you?
Yes.
You do? Try and pull the thing at the ink out, please.
Too small.
Do you have anything you can use to pull it out?
You can pull Mark.
Call who?
Mark.
Why Mark?
I don't know. Weak friend.
Mark can't help me now. Do you have anything that you can use to pull it out? I wonder if I can just write with this.
No.
See, I thought you had me something to help. You just took out a chocolate bar.
I'm sorry, I don't have anything. Let me try. I don't have to get it out there.
Oh dear.
Maybe the chocolate can help.
Hang on. Oh, no, that's not right.
Can you put in another side and...
have tweezers in your room, do you? No good to me then. Alright, I'll have to just type, I'm afraid, I'm sorry. I can't draw any pictures. I know it's sad. I know art. I'll just have to type it. Notepad. Okay, so in this one it's can you read it again? So there's a copper wire wrapped around 100 times?
Yes.
Yeah.
And the radius 5 centimeters around the magnet.
Okay. Yeah.
The magnet of density of 2T is removed over 0.25 seconds. What is the EMF?
Okay. So the formula here, V equals 100 delta phi over delta T as normal. You know why I wrote 100, don't you? Because it's 100 loops. What's changing here in this story? What? The B is changing, yeah. Changing from what to what? From 0 to 2. So here it'll be 2 minus 0 over 0.2. And what's the formula for area?
0.06.
100 pi or squared. So it's 100 times pi times or squared times 2 over 0.2, which is 10. So what's this, please? That's the answer.
1.57 volts.
Oh wait, I think I know what this is for. This is to pull it out. Oh.
You got it.
Oh. Hang on. So let's put the new one in. Okay, it's the program, so. Okay, what's the answer here, Andy?
1.57.
1.57 volts. Okay. Why is it 2 minus 0? What happens is, at the start, there's no magnet, and then I say in the question, I move a magnet over it. Isn't that what I said, or not? Oh, well then it's the opposite. There was a magnet of 2 and then I removed it. So it'd be 0 minus 2. But I don't care about the sign. Because the sign... Yeah, there was a minus as well.
It can be changed minus or minus.
Yeah. I mean, if I want to be clearer, I should really put a minus here. And like you said, this should be... 0 minus 2. That's 0 minus 2. But it's still the same number, just maybe a different sign. Here you don't care about the sign because it is only for the direction. So I don't really care about the sign. That's the circle with the line through it. But I can't write right now. Is there another question? How many questions were there?
One more.
What?
Big one.
Oh, great. Okay. Go for it.
What is the
What's this? Area?
Yes.
Yes.
How to
Pi or squared? It's a circle.
What is the 10?
The 10? Oh, this divided by this is 10. Isn't it?
R is 0.05.
Yeah. Yeah?
And delta C is
2 minus 0, yeah.
2. T is 0.25.
I thought you said T was 2.
Wait, it's not 1.5.
I mean time.
Oh, time is 0.2, yeah.
So I got
And also I would,
0.25.
Oh,
yeah,
okay.
2.5.
So then it's not 10 here, it's 8. Is this still right though, Andy?
No.
Okay.
I don't know about it.
I thought you said 0.2.
It's 0.25.
Okay. Seconds, okay.
2t around over.
Okay. We'll fix the answer then. It'll be a little smaller, like maybe 1 point. What? What am I looking at?
4.
Yes. Yes.
Yes.
She got 6.28. Okay, right.
Yes.
Good job. Finally, good, okay. Right, okay, good. Okay, what's, Andy, what's question 5 then?
A small generator uses a magnet or flux density of 5 Tesla. The rotating train is a small 30 centimeter by 10 centimeters. Consider the plane moving from vertical position to a horizontal position. The plane rotates with frequently 50 Hz.
Yeah?
And question A is, what is the flux linkage and
Flux linkage, yeah?
and
That's the flux, the phi.
phi?
Yeah.
And phi.
Okay, so the first one is what is the phi?
The n phi when the plane is vertical.
Okay, so at the very beginning I want to know what the flux is when it's vertical. So the formula, phi equals BA cos theta. You remember this formula? What's the B here? 5. And the A, 0.30 times 0.10. And then, what's the theta when it's vertical? The theta is 0. Because the theta, you can check the last lesson, but the theta is the angle the normal makes with the field. And the field is going this way, and the normal is also this way, so the theta is 0. Okay, so what answer do you get here then? Yeah, 0, is it 0.15? Well, there it is there. I use this formula. Phi, you know that symbol?
Yeah.
Yeah. This is a Greek letter. No, that's my mouse. This is called phi. So phi is BA cos theta. You remember this formula from last week? Or not last week, but this week. So there's the B, there's the A, there's the cos theta, and I think this is the answer. Did you check it, Andy? The numbers here? The angle is 0 at the start. No, cos 0 is 1.
Oh. Oh, I think cost zero.
No.
What's B and what's A?
A is area and B is flux density.
0.1.
Yeah, okay, what's the next part, Andy?
What is the flux linkage M52 when the same is pointing?
So, that would be 5 times 0.30 times 0.10 times cos 90, which is 0.
What's W?
Webers. Dude, you really need to watch the videos, okay? Right, what's the next part, Andy? C.
What is the time take to go from vertical to horizontal?
Okay, so I think you can tell me the time. In the question, I said the frequency for the rotation is 50. So what's the formula for the time? Do you remember from circular motion? It's 1 over f. Yeah, which is 1 over 50, which is 0.02 seconds. But be careful. Look, that's the time to rotate fully. I don't want that time. How much of the time do I want? Do I want all of it? Half of it? A quarter of it? A quarter, yeah, because it goes from this position to this position. Where are you?
Here and here.
It's a quarter, yes. So it's a quarter of the time. So divide by 4. 0.005 seconds is the answer. Grace, I use this formula, but I need to divide by 4.
Area?
No, this formula. You know this one? Yes? Okay, what's the next part, Andy?
Compute delta N5 over delta T and so what is the induced strength?
So what's the voltage then? Yeah? Okay. Andy, in the question did I say how many times the wire is wrapped around?
No.
It's just one wire?
You didn't mention about
Okay, so it's I didn't say what it was, okay. So we have area, B equals 1, and then the time is 0.005, and then we go 0 minus 0.15. Okay, so what's the answer here then? Is it like 30 volts or something? What is it?
30.
Yeah, what's the answer here?
30.
It is 30? Okay.
0
0
minus 0.5.
minus 0.15. Sorry, do you need me to make it a bit bigger?
This delta N times 5 over delta T.
Delta. Show me. Can you write it down? What's your... Yeah, it is, yeah. Except I just put the N in the front. The N is 1. Yeah. I just put the N in the front. And what's the last part? That's it, okay. Alright, next now. But I think the next lessons. I'll go back. The next lesson is easy. Very easy. About,
Yes.
hang on, let me just stop the video here.